The subsequence of an infinite sequence is an infinite ordered subset of the original sequence. So on your first problem on your sheet, I gave you a set statement that's a little bit more vague. Try to pull that a little bit and say, okay, if I use that definition, it almost seems like it's right. What would be wrong with that definition that I gave you on your sheet? So what could I do? How could I use that definition I gave you to mess with the original sequence and pull something that isn't actually this? Kate?
Isn't the ordered element?
Yeah, I could just take them all out of order, right? What else could I do?
It says it's infinite order, but you cannot do an infinite amount. You can just do a training 5 elements.
Yeah, if I do 5 elements, everything converges, right? So this definition needs that word infinite, it needs that word ordered. So you need to actually pull them in order off of the original list. So just to show you what that looks like, if I have my original sequence, I pick off some of them, but in order. So it's not like I'll go A1, A3, A2. I won't go backwards into the original sequence. I'm not allowed to go back. By the way, I pulled off here, I think I started to, yeah, I pulled off here in order the Fibonacci sequence. When I was, I know I'm recording this and putting it on YouTube. When I was here as a junior faculty member, I was pretty young, and we'd park in the moat, but I'd always come late because I was coming from Nyack and driving up, and my friend and I would carpool, no place to park, and then people would park badly if they were here first. And it would just make me so angry to come and find this space that was almost a parking spot, but just messed up under the moat. So I thought, I'm going to start slashing tires, but in order of the Fibonacci sequence. I'm first going to slash the first car I see, then I'm going to skip to the second car, then the third car, then the fifth car, and then just see if anyone notices the pattern of how the tires were slashed.
They noticed it. I did notice.
They'll call me the Fibonacci tire slasher. All right, next definition. A monotone sequence is a sequence that's either non-increasing or non-decreasing. I'm using non-increasing because if I use increasing, the word increasing usually means strictly increasing. So I'm allowing for the next element to be the same as the previous or bigger. So non-increasing means it might be level sometimes. So this is an example of a non-decreasing sequence. They're also called monotone sequences. They just go one direction. So I think you have on your sheet a question that says, why did I say this? Why did I say non-decrease? This seems, sometimes I think when you're sitting from your seat and looking up at what I'm doing, you probably think, she's overcomplicating things. I think I wanted to go through your questions today and kind of tell you why I'm being precise and exact. I have to be extremely precise and exact. There should be pencils moving on that sheet that I just gave, because there's now about 4 or 5 questions. What question are we on now? Right, so that should be completely filled in on that portfolio sheet. I'll give you a minute to catch up.